Okay, so let's start this live stream. Okay, is sound good? Yep. So something to note, I have changed the layouts of the buffers. So Vulkan tutorial. So in the index buffers we have the vertices buffer, and then the indices buffer. It still like this in code, but on the GPU part, the vertices and the indices are in one buffer. So yeah, here they say the previous chapter already mentioned that you should allocate multiple resources like buffers from a single memory allocation, but in fact you should go a step further. Driver developers recommend that you also store multiple buffers like the vertex and the index buffer into a single VK buffer. Okay, so let me show you what I have did, because I didn't record it. I did it off camera. So and then src/main edit anyway. So as you see, we still have the vertices in the vertex buffer and the indices in unit 16, an unsigned short pointer. So they are both pointers, but where is it? In here I have commented the create vertex buffer, and I have changed the create index buffer into create vertex index buffer. So let me show you what it looks like. So here we go. The create vertex buffer is commented, and here is the create vertex index buffer. So we have a buffer size, which is the size of vertices plus size of indices, and we have staging buffer, and we create a staging buffer memory. So we create a staging buffer, we allocate it, and then we have a void data, and then we map the data to the staging buffer. Then we mem copy the vertices first into the data void pointer. Then I did something with pointer arithmetic in here. So let me explain what I did here. So in C, void pointer arithmetic is illegal. So I have cast the data buffer into a vertex pointer, and I increment by the size of vertices divided by the size of a single vertex. This size of vertices divided by the size of vertex means that we will get the how many vertices are in that vertices buffer, vertices pointer. So we have 4, so this must gives us a 4, and then we add the 4 to this vertex pointer, this data which we have casted to a vertex pointer, which it's like we did, it's like doing this vertex pointer data, and then at 4. This is exactly what I did. It's the exact same thing. This is exactly the same thing as this right here, this line of the first parameter of mem copy. So it's like we added an offset to the data buffer so that we can write indices to it without touching the vertex data. So yeah. And then we unmap the buffer, the staging buffer. Then we create another buffer which we will have the VK usage index buffer and the VK buffer usage vertex buffer bit. They are both must be set. And then we copy the staging buffer into the vertex index buffer, which is another it's the buffer that I have created in the state structs. Then we destroy the staging buffer and the staging buffer memory. Another thing that I have changed is in, I think it's record commands, I guess. Record command buffer, yeah. Record command buffer, create command buffer, create pull command, and then record command buffer. So here in the vertex buffer it stays the same, the offset stays the same, and when we bind it, it's also the same. But when we bind the index buffer, we give the offset of it, this is the offset, we give it the size of vertices, so that it offsets to the place where the indices start. And then the VK command draw indexed stays the same, of course. So yeah, so let me show you that it still work. So make clean and make run. So yeah, it still work. What the heck happened? Segmentation fault core dumped. Why is that? Valgrind. Come on, Valgrind, run. Welcome to Vulkan. Okay, so what's the problem? Invalid read of size 4. Main loop draw frame recreates swap chain, create swap chain, Vulkan deliver, Jesus. Are we compiling with -G? Okay, so create swap chain in 335. Okay, 335. VK get swap chain image cache. What? Invalid read of size 4. VK create swap chain. Is the image count? Failed to create swap chain. failed to create swap chain. Okay, so it fails to create the swap chain. Let's try and decrease this image count. 64. Yes, it's the image count. Okay, that's why. So if I increase this 128,